Okay, so we're going to talk a little bit about what happens with the Fungarium. A lot of people have already spoken about this, so we'll go over this really fast. So the uses for your specimens in the Fungarium. Angela, you can just go ahead and click through. I think there's 4. So identify a new species. You can go back to type specimens. So those are the specimens that were used to define a new species, and you can compare them. Thank you, Angel. You can look at changes in distribution. This is something Barbara mentioned. So you can see, due to climate change or human use of habitats, has a mushroom disappeared from a certain area, or has it moved its distribution? Monitor old growth systems. There are specific species of fungi that are indicative of really old forest or highly disturbed areas. And so that can help people identify areas that need to be protected. And it can inform our understanding of the evolution of fungi. And this is with the physical characteristics as well as DNA that can be taken from these specimens. Okay, you can go ahead and click. And with this, I also want to talk about how you can use this information. So with this, we're going to do an example. Barbara mentioned that herbaria are open source, which is a new term for something that's been around for a long time. You are welcome to go to Microportal and use this data. You can, here I did a search for this pepper pot earth star, and I pulled up all of the samples that are available in herbaria and museums. And so you can see that the distribution is global here. You can limit it by region. Go to the next page. So after you do a search, you can get all of the associated data with it, the metadata. So here you can see these are each of the listings, and you can't see all of it, but it does list like habitat, everything that was on the label you can download. So I did that for this. I downloaded all the data from Myriostoma. Go ahead and go to the next slide. And with this data, there were 214 total observations I was able to download. Go ahead and click to the next one. They were from 24 countries, including one that was just labeled Earth. So you can see you can be as broad as you want to be, although something a little bit more narrow would be better. The oldest specimen was from 1695, although most of the specimens were from the 1800s, 1900s, and the 21st century. Okay, go ahead and click. And so with this data, I wanted to show you what you could use it for. So if I was interested in finding this mushroom, I could use this data to look at when the best time of year would be to go out and hunt for it, where it would most likely be found, so with what species and what type of habitat. Go ahead and click again. And then I can use any DNA that's associated with the specimen on Microportal to determine if it is a similar species to Myriostoma cauliforme, or is it Myriostoma cauliforme? Okay, so I did some quick analyses to answer these questions. So here I took all of the samples, and you can see that the highest abundance of observations were in the fall. So on the y-axis here, we have percentage of the total specimens that I was able to download, and on the x-axis, it's each month. You can see September and October have the highest number of observations. So that would be my best time of year if I wanted to go out and find this mushroom to go. Can go to the next one. And so where would I look? Only about, I think it was 38 of the observations had habitat information, and it varied widely. I had to kind of go through and curate it. So that's why it's kind of a wide array of types of habitats and plants. But juniper, oak, and cedar elm, which is all found in the Austin area, is where this mushroom is normally found. It's associated with these species. So I would go to a juniper oak forest or a mixed forest in this area. Okay, and then the last slide. This one I wanted to show you. We are trying to get DNA sequences for all of our samples. And this is kind of a plug for a possible future workshop. So here I have all of the gene sequences I downloaded from NCBI, which is a publicly available sequence repository. All scientists who publish papers are required to deposit their sequences that they get into this database, and anyone can go on and download them. So all of the data I've used is publicly available. So the BFL002 is the specimen that we collected from BFL, and then there's 4 other species within this genus, and then I have another species that's more distantly related. And so you can take this DNA and you can compare it, the bases, to look at similarities and differences. So you can see that this G. saccatum has more bases that are different from the other species, and the other ones are more similar. So you can go ahead and click to the next slide. And so with that, we can make a phylogenetic tree. And what this shows is similar to the one we saw at the very beginning that Angel showed. We're looking at through time evolution of this genus and how they're related. So you can see the BFL specimen is most closely related to Myriostoma cauliforme. So I would say it is definitely Myriostoma cauliforme based on the physical characteristics that we saw and the DNA. You can go ahead and go to the next slide. And so with this data from Microportal, you can figure out when the best time of year is to look for a mushroom. And ideally, you probably want to do this for something that you're more interested in finding, like chicken of the woods or morel mushrooms or something that's really good to eat. So fall for this one if you want to find the pepper pot or star. And then also look in oak juniper forest. You can go ahead and keep clicking. Yeah. Thank you. I shouldn't have done animations. And then with this data, I did find that it is Myriostoma cauliforme. So this is all analyses that you can do with this publicly available data. You can go ahead and go to the next slide. And that's my plug for future classes I'm hoping to do with Central Texas Mycological Society, including how to use Microportal, how to download the data and curate it for your own analyses. A workshop on DNA sequencing, so how sequencing works, what is the fungal barcode region, which is the region that all mycologists use to identify a specimen to species, and how to use these DNA sequences to maybe make a phylogenetic tree, and then an introduction to NCBI, which is this other database I mentioned, where all of these sequences are available. Also, I'm a huge advocate for R coding, which is open source and free. This is a common theme. So doing some workshops on data analysis and visualization using this. And then also lastly, some microscopy courses or workshops would be really fun to do.